last topic we want to look at in this section is applying these equation solving techniques to solving a formula for a specific variable. For instance, in example 6, we have the formula d equals rt, or distance equals rate times time, and we want to solve that for t. These can look more confusing because we've gotten rid of, in this case, all of the numbers and we're only dealing with letters, but our same problem solving or equation solving strategies apply. First, we want to simplify as much as possible. Then we want to isolate our variable terms and our constant terms. Those first two steps are taken care of for us because in this case, d is a constant term because we're treating t as the variable in this case. And r times t is our variable term. So we're up to the step where we can multiply both sides by the coefficient, or I'm sorry, the reciprocal of that coefficient. So in this case, we'll multiply both sides by 1 over r, which will give us d over r is equal to t. Or we could rewrite that, since equations work in both directions, we could say t is equal to d over r. So while this looks more complicated, can look more complicated since we got rid of all the numbers, this particular problem took one step to solve, just multiplying both sides by the reciprocal of that coefficient. In example 7, we have a slightly more complicated problem, but our goal is the same. What we want to do is isolate h by itself. We want to write this as h equals some expression in terms of all of those other numbers and letters. We can start this the same way by identifying the coefficient of that variable term. In this case, we have a few pieces going on, but we'll just focus on that 1/2. The reciprocal of 1/2 would be 2 over 1. So we'll multiply both sides by 2 over 1 to get 2a is equal to b times h. We still have a coefficient, a value being multiplied by that h. So we'll multiply by its reciprocal, which would be 1 over b. And that's going to give us 2a over b is equal to h. Once we've isolated h by itself, we know we've got our answer. So in this case, h is going to be equal to the expression 2a over b. In example 8, we have the formula I equals PRT. Where we want to solve for t. This is very similar to example 7. We have two different factors being multiplied by t, and we'll speed this problem up a little bit by multiplying both sides by the reciprocal of p times r, which would be 1 over p times r. Essentially, we're doing the same thing, just in one quicker step. And that's going to give us I over p times r is equal to t. In example 9, things get a little bit more challenging because now we have a more complicated expression, but we can still get through this pretty quickly. What I'm going to do is, well, first we'll rewrite this the same way we did the others, identifying that variable that we want to solve for. Now what we can do is sort of think of this entire expression f minus 32 as being that variable term, since it's all contained in parentheses. What we're going to do then is identify that coefficient out in front, that 5/9, and multiply both sides by that reciprocal. That's going to give us 9/5 times c is equal to f minus 32, which leaves us with one last step, which is to add 32 to both sides. Giving us 9/5 times c plus 32 is equal to f. So we've taken that original expression and now solved for that other variable. I think it's fair to ask throughout a math course why we're doing a particular type of problem. One answer is always going to be just improving your algebra skills if we're doing algebra problems. So part of this solving a formula for a specified variable is just to expand our algebra skills, get a little bit more comfortable, and help us think of other problems as even being a little bit easier. But in this case, this last example, this is a very practical case beyond just building up your skills. If we look at that first equation, c equals 5/9 times f minus 32. This is the formula for converting degrees Fahrenheit to degrees Celsius. The way this equation is written, we can plug in a value like 32 degrees, evaluate this expression, and we would get the equivalent temperature in Celsius degrees. Then what we've come up with, where we solved for f, gives us f equals 9/5 times c plus 32 is now an equation or a formula for taking degrees Celsius, something like 0 degrees Celsius, and translating that into something in degrees Fahrenheit. So again, a lot of this is just about building up algebra skills, getting more comfortable and confident with these abilities, but there are also very practical applications to taking a formula and solving it for a different variable. It just depends on what that formula does and what types of questions we might need to answer.